So the quantum field operator is usually written as this one, this equations. So this equation contains infinitely many momentum values, complex exponentials, creations operators, annihilation operators, and quantum states. So since calculating everything exactly by hand is almost impossible, textbooks often introduce a toy method. Okay, a one-dimensional universe. So instead of our real three-dimensional universe, imagine the particles can only move along one straight line here from 0 to 10. And every particle lives somewhere between x equal to 0 and x equal to 10. So this removes unnecessary complexity. So only two possible momenta, normally equal to 0, positive or negative 1, or positive or negative 2, or positive 3 and negative 3. So there are infinitely many momentum modes. Instead, they allow only momentum 1, slow particle, and momentum 2, fast particle. So uh, instead of infinite possible momenta, we have only two here, momentum 1 and momentum 2. So much easier. So the vacuum state. So they say the quantum field is completely empty. So in QFT, empty space is called the vacuum state. It is written as zero kit. This does not mean nothing exists. Instead, the quantum field exists, but there are no particles in it. Think of an empty swimming pool. The pool is still there. There is simply nobody swimming. So likewise, quantum field is the same as meaning exist, but there are the particles there. So the current value of the field, the the current value of the field is equal to 0. This is uh, delta phi is equal to 0, or field value is equal to 0. So this simply means at this instant the field has no particle excitations. No wave has been created yet. The right particles. Um, so the particle here, there are no particles here. For example, if there are no particles, because we are still in zero Kelvin, so there are no electrons, there are no photons, no excitations. So action one, create a particle. So now comes the interesting part. The creation operator is a dagger. So applying it to the vacuum gives a dagger. 0 Kelvin is equal to 1 Kelvin. This means before we have the vacuum, 0 Kelvin, no particles. Then we have the creation operator here. So after we have the 1 Kelvin, one operator exists. The field has been excited. So think of plucking a guitar string. So before you have a straight line guitar string here. So after plucking, you have a wave. So the wave is the excitations. In QFT, the particle is that excitations. So why momentum one? The operator actually creates a particle uh, in a specific momentum state, no? Instead of writing uh, a dagger one, they simply say create one particle with momentum one. So that means before vacuum particles. There are no particles, so there are no particles. After the particle, after we have the particle spin here. So one particle momentum is equal to one. So what will happen? What will happen next? Usually, the next steps are step one. For the vacuum, we have zero Kelvin. Then for creating the particles, we have the E1 dagger. Zero Kelvin is equal to one Q1 Kelvin. So one sub Q1. Then we have the step three. Field value becomes non-zero because one quantum has been added. So use the annihilator operator here. So E sub 1 to remove it again. The E1 1 get is equal to 0 get. Now the field returns to the vacuum. So the big picture here. So this numerical example is not trying to solve the four quantum field equation. Instead, it demonstrates how creation and annihilations operator change the state of a quantum field. Start with vacuum 0, so the field exists but contains no particles. Apply a creation operator in dagger, one particle, a quantum of the field appears in a chosen momentum mode. Apply an annihilation operator, A. That particle is removed and the field returns to the vacuum. So this is a central idea of quantum field theory. Particles are not fundamental objects moving through empty space. They are quantized excitation of underlying fields. So the creation and annihilation operator are the mathematical tools that add or remove these excitations.